All right, welcome to Human Population Issues, Chapter 8 of AP Environmental Science. In Chapter 7, we talked about how to talk about populations, and in Chapter 8, we're going to talk about population issues. So this slide is talking about how the world is not growing at an even rate. In some countries and parts of the world, we actually see a loss of population. Oops, sorry about that. And in other places, we see a huge increase. And this is making an argument for that inequity across the world. So in addition to all the factors that we talked about that influence population growth in Chapter 7, here's some additional influences on population growth. So demography is the study of populations and their characteristics. So here we have birth rate typically exceeds death rate. There's an ultimate carrying capacity for the human population, and unlike other organisms, we have accumulated knowledge and can adjust the lifestyle and our impacts accordingly. So what that means is hopefully we can increase the carrying capacity with technology. So here are some additional biological factors that impact human populations. The first one is the total fertility rate, or TFR for short, which is the number of children a woman has during her entire lifetime. We've talked about replacement level fertility, and that's the number of children needed to replace everyone in the population. This varies within regions, but it's typically 2 children for every 2 parents. And then there's zero population growth, which is where birth rate equals death rate. And that's where we're trying to get to eventually. So on this slide, this is an issue we've talked about before, that as the population grows, so does the demand for resources, especially food. And as human populations can only increase the size if other plant and animal populations decrease in size, or that we get more out of each acre of farmland is another way of thinking about that. So hunger and food production sometimes and most of the time equals environmental degradation. So to continue our thought on hunger and food production, we can look at underdeveloped countries and more developed countries and compare what they eat. And people in less developed countries generally eat and feed at the lower trophic levels, so that would be closer to just plants, versus those in a developed world that tend to eat animal products that are higher up on the trophic levels. So long-term environmental health may be sacrificed for the short-term population needs. Humanitarian food aid is also in place to help with some of this. So with all these potential issues we've sometimes forget to talk about solutions. And so this is how this came to be, debt for nature swap. A debt for nature swap pays by developed countries. They pay less developed country to return protected habitat into keeping it into protected habitat. And then as a result, developed countries pay off any debt. So it's a swap for money for in return protecting lands. Population growth is in 4 stages, so we've talked about these 4 stages, but it's important to remind you of them again. There's stage 1, which is the pre-industrial stage. There's stage 2, which is the transitional stage. Stage 3, which is in the industrial. And stage 4, which is the post-industrial. And you can look here at the birth and the death rate. And in the stage 1, we have a pretty high birth rate and a pretty high death rate. So the total population stays pretty low. And then usually because of the introduction of some medicine or something comes into place, our birth rate stays pretty high, but our death rate goes down. And as a result, we have an increase in our population. And this is during that transitional stage. And during the industrial stage, our birth rate comes back down to almost to our death rate. And our population starts to level off. And then in the post-industrial stage, our birth rate is actually at 0 or below 0. And we see our carrying capacity reach and then the population eventually coming down. And that's happening in places like Europe and Japan. We see this negative growth or zero growth. Here we have a picture of a bunch of bicycles, and as you can see, the mode of transportation here is there's a lot more bikes than there are cars. Although cars are available, there's a lot more individuals riding bikes, and as a result, that is one way that populations can get around. Maybe not as effectively, but can get around in high numbers. So that's one solution for our issues. So another area that we need to talk about is net primary productivity. And this is the total number or the total amount of solar energy converted into biochemical energy through photosynthesis. And then to get the net, because it's not total primary productivity, it's net, we have to minus the energy needed by the plant. So how much the plant makes minus what the plant needs for its own metabolic requirements. And so this is important because it's a measure of food resources available on Earth for all living organisms besides plants. And without human activity, it is estimated to be 150 billion tons of organic matter every year. So if we eliminate humans from the equation, that's what it is. So humans do have an impact on the net primary productivity, and there's two different ways, or two different categories. First, right off the bat, there's a 12% decline due to deforestation, and this number can go up, it can go down, depending on our actions on our forests. The next one is there's a 28% used of our net primary productivity is used for food, building materials, and energy. So that leaves 40% of the Earth's net primary productivity is committed to the use of humans. And that's going to be an important percent here in a second. So we've talked about theoretical carrying capacity, and the way we calculate that is through net primary productivity. So if we have 100% of net primary productivity, so all plants, and we currently use 40% for these calculations when they were done when the population was 6 billion, we can put 6 billion here, and we can cross multiply and divide to find x. X is then roughly 15 billion. So assuming all plant growth was utilized by humans and no other effects like pollution or disease are taken into account, then our theoretical carrying capacity for the number of people our Earth can carry is 15 billion. Now, that's the assumption there is that no other land that is currently having plants on it will be converted to anything else, and we see that happening already. So even since these statistics have been done, this has come down to 14 billion by most economists and biologists.